Statistics is a study of how we collect, analyze, and draw conclusions from our data sets. In this introduction to statistics in Python, we'll be looking at summing statistics, random numbers and probability, distribution and central limit theorem, and correlation and experimental design. So welcome back to the channel and welcome back to Excel Island, where the goal and objective is to learn and master Python over the next 100 days. Today is day 41. On day 40, which was yesterday, we started a new course out of the 9 courses in this data analysis in Python career track on the DataCamp platform. So we're actually looking at introduction to statistics in Python. So we want to learn how to collect, analyze, and draw conclusions from data sets using statistical method. So we started yesterday and we got introduced to what statistics is. We learned all about the difference between descriptive and inferential statistics. We also learned that these descriptive and inferential statistics can be grouped into what is called numerical or also quantitative data and categorical or qualitative or data sets. So this is what we covered on yesterday's live stream, just for few minutes of yesterday, less than an hour. I also looked at what is called measure of central tendency, which is the mean, the median, the mode. So we want to look at how to work with the mean, how to use mean, median, and mode, and other stuffs for our data analysis. So without further ado, we'll just get back to learning and start practicing. So that was where we stopped on day 41 when I had a little bit of challenge with my source of power. So I'm just going to continue from there really quick. So for this introduction to statistics, we have our data sets. We'll be covering 4 chapters as usual. We'll be covering 4 chapters as usual. Then we have the data sets. This are meal deal sales, this food consumption data set, and this world happiness data set. So I'll drop a link to this data set under the YouTube description so you can have access to this data set and also practice your statistical skills also. So if I go back here, I'll just click on continue. So if I show you what it looks like really quick, yeah. So data analysis in Python. So in yesterday live stream, we've covered basic statistical knowledge, which is what is statistics, descriptive and inferential statistics, data type classification, and we looked at meta or measure of center, which is definitely the mean, median, the mean versus median, and so on. I'll just continue from here so you can continue. So we have a challenge to start yesterday after. So this was what we learned 23 hours ago. So the goal is to use just 1 hour daily to cover this Python learning journey. So the goal is to show up few minutes every day, which is going to accumulate over a period of time, and which is one of the best ways to learn, rather than just sitting down or straight up probably 2 3 hours try to learn once in a week or once in a month, which is not the best way to learn these highly technical skills. So we just look at mean and median. So we have our data sets here also. So I've created a Python or Jupyter notebook yesterday. So I'm just going to launch that so we can also start playing. And as you can see, it's still blank. We've not imported our libraries. I'll just import our libraries really quick there. So let's read the instruction and try to solve this. So if you want to know what is statistics or the difference between descriptive and inferential statistics, just go to day 40. So we covered all of this on day 40. And what is measure of center, which is mean, median, and mode. So in this chapter, you'll be working with the food consumption data sets. So we have the food consumption data set here also. Food consumption data sets by NU3. So the food consumption data set contains the number of kilograms of food consumed per person per year in each country. Okay, that's interesting. So in kilograms, it's showing us the number of food consumed by person per year in a country. And food category, which is the consumption is a category, and its carbon footprints, which is the CO2 emission column, measured in kilograms of carbon dioxide or CO2. So in this exercise, you will compute measure of center to compare food consumption in the US and Belgium using your pandas and numpy skills. So pandas is imported as PD, for you and food consumption is preloaded. So I'll just go ahead and import pandas, my Python library from here also. So let's just go back a little bit. I'm gonna say, okay, let me use this one. So I don't want to copy my pandas. Okay, we'll use pandas here. We're going to be using other uh, other libraries also. So I'm going to be using pandas. We're going to be using NumPy. I'm going to be using NumPy. Probably we'll be using some other libraries also, but we've learned all about pandas, NumPy, or we've learned also about matplotlib. So we've learned how to use all these libraries. That's why I'm importing them. So I'm not going to cut this out, run this code. So now next thing is to connect to this data set here. I want to connect to this food consumption data set. I'm going to use read the food consumption data set. Read the food consumption data. So it is called food consumption. I'm just going to name it food. Let's just name it as food, or what was its name there? So we need to import numpy as PD also. Subset food consumption to get the rows where the country is USA. Food consumption. It is named food consumption. Let us just name the data frame as that also. So food consumption equals to food consumption underscore CSV. So it's going to be food consumption. So this is going to connect this pd.read underscore CSV is going to, this line of code will just connect to this data set that is in the same environment or the same location as my Jupyter notebook. If I run this code, so we shouldn't have any error there. So let's look at food consumption. You can see, so we have over 4,000, 1,400 rows of data and just 5 columns. If I just say food consumption underscore edge, so we have this unnamed column, we have the country, the food category, the consumption per individual in the country, and the CO2 emission. So we want to work with this data set. So I could just say food consumption dot shape. You can see we have over 1,400 rows of data and five columns. 1, 2, 3, 4, 5. So let's see what we need to do here following this instruction. So import numpy as PD. So I'm just going to say import numpy as PD from here. But numpy. So numpy is used to work with statistical data for our, we want to calculate our mean, median, mode, all those statistical analysis. So you're going to use numpy as MP. So the next one is to subset category for US. So we want to subset for rows. We want to filter for rows where the country is US. So that's what we need to do here. So I'm going to say US consumption. So it's going to be food consumption. Food consumption where the country is USA. So we're going to select the country column. Just a minute there. So we're going to calculate the mean consumption in USA. So let's say food consumption. We need to mention food consumption again. So I need to include the data frame here again. Oh, okay, this is what I need to copy. So food consumption column, food consumption data frame. Uh, nope. Where the country column is equal to USA. So this will give us our result. So we want to subset for rows, we want to return rows where the country column is USA. So let's try this in this line of code here. So it's going to look at this country column and only return rows that are equal to USA. You see, that works pretty well. If I call on USA consumption now, let's see. So we have view, we just subset for only USA columns, USA rows rather. So that's how to filter in Python. So I'm going to do dot edge. Dot edge. This is just a few rows. We can just do USA consumption dot shape. So out of over 1,500, over 1,400 rows of data, the US record there is just 11 rows of data. This is now under 5 columns. So we just work with this simple data frame here. Interesting. So what we need to calculate is to calculate the mean. So calculate the mean consumption in the US. So I'm going to say NP. So it's going to be NP mean. So NP is referring to NumPy, this NumPy array. NP dot mean. So to calculate the mean. Then I'm going to mention the data frame. Open bracket, food consumption. They want to calculate complete mean consumption in the US. Mean consumption in the US. So consumption. So then the consumption column. We want to look at the mean consumption for the year, which is the average consumption. That would be curly brackets, then consumption column. Is it named consumption column? Let me double check the spelling. Exactly. So consumption column. So let me just copy this line of code here and make use of it in this. So I'm just going to get rid of this main, this print column here. So this is going to say the mean of the consumption column for this US data frame. If I run the code, so the mean from all these data sets is 28.11. Let's see what we need to calculate next. Calculate the median consumption in the US. The median consumption. The median is similar, so I'm just going to change this mean to median. Control C. Get rid of this. So instead of mean, I'm just going to change this to median, just to make the calculation super fast. So the median consumption for US is also so the median consumption is 8.89. So you can see that. So that's how simple using NumPy to do some simple calculation is. So let's submit the line of code here and see. Let's run this whole code. You can see we got same results. So the mean is 28.11, 8.89. See. So let's submit that. Oh, did you call np.mean on the consumption column of US consumption? I did np.mean. That is exactly what I did though. So what's now the error here now? If this could be correct, why is there an error here? Let's get help and see what we did wrong there. Probably we just missed probably a line of code. np.mean. What was the problem here? Median US consumption. Is sometimes DataCamp just acts up. NP mean. Oh, I was doing it on food consumption rather than US consumption. You can see, so it is my mistake there. So instead of it should be US consumption. You see, sometimes you just have to look a little bit deeper. So I'm not, I made a mistake. US consumption. So I'm calling it on all the old data frame, and that's not what we want. We want the US consumption. Oh, great. You can see my mistake there. So you have to be very careful. Which data frame are you using? So my mistake was using food consumption rather than US consumption. Okay, voila. So that's our result. So marvelous. Mean and median calculation. So your calculation shows that the mean and median consumption in the United States are quite different. Let's get an even better understanding of the data by taking a look at its distribution. Okay. So mean versus median. So we're on this channel called mean versus median. So in the video, you learned that the mean is the sum of all the data points divided by the total number of data points, and the median is the middle value of the data set, where 50% of the data is less than the median and 50% of the data is greater than the median. Okay. So in this exercise, you compare these two measures of center. Pandas is loaded as PD, NumPy is loaded as NP, and food consumption is available. So let's see what we need to do here. So we want to use matplotlib now. So import matplotlib as PLT. We're going to run the code. So matplotlib is for visualization as PLT. So it's going to be, so we want to visualize our data sets. So I'm going to copy this line of code. So use this matplotlib for data visualization. So let me go back up a little bit and run this line of code again. Correct. So let's see what we need to visualize in this instance. So subset food consumption equals rice. So we want to look at rice consumption. Oh, that's good. So I just love to copy some line of code. Let me just copy this. So we want to look at the food category. So food consumption, then food category. So equals rice. So we want to look at food category. Where the food category is equal to rice. So let's visualize food category equals to rice A and see. So that means to be seeing rows. This category, instead of seeing pork, poultry, beef, lamb, goat, or fish, we should be expecting just rice records. Rows of rice. So you have 130 rows that are record for rice. I just say underscore head. You can see, so we have rice category here. Just love to know number of rows we are working with, just 130 rows of data. So let's see the visualization we need to do here. So histogram of CO2 emission for rice and show PLT. So create a histogram of CO2 emission in rice consumption data frame and show the plots. So I want to show the histogram for rice consumption. So that is going to be histogram for rice consumption. So for rice consumption, I want to show the CO2 emission. So it's going to be CO2 emission, the CO2 emission column. Uh, dot histogram. Let's see if this is going to work. Then PLT dot show. We need to show the plots. PLT dot show. Let's see if you run into any error. Well, I can see the consumption of rice. Now let me now copy this line of code. This is the CO2 emission for consumption of rice. So we want to see the CO2 emission for this rice consumption data only. So that's what we did here. Voila. You can see. Let me just put PLT.show here. It's going to show us the same way. So this is our CO2 emission for consumption of rice. You see that for consumption ranging from see there are less consumption or for less emission within this range here. But let's see how we analyze the data set here, the result of this of the calculation here. Let's see. Okay, so take a look on the CO2 histogram we just created of different countries' CO2 emission for rice. Which of the following terms best describe the shape of the data? Is this left skewed or right skewed? So if you know say, is it left skewed? So this is definitely right skewed. Correct. So it is right skewed because there's less consumption to the right. So use .arc to calculate the mean and median for CO2 emission for rice. Want to use this .arc calculation to calculate the mean and median for CO2 of rice. Okay. So calculate the mean and median of CO2 of rice. Okay, let's see. Since we know our histogram for our emission for histogram for CO2 of rice is right skewed. So let's see the mean and median then. Okay. Mean and median consumption for CO2, that is rice consumption. Rice consumption. Let's see. Okay. So we're looking at, okay. So, so we need to pick the rice consumption data. That should be dots. Yeah, just checking, just double checking to be sure. Okay. Rice consumption, open brackets, the CO2 emission column, CO2 emission column, then dot arg. Once you use dot arg, then we want to calculate the mean and median. So open brackets, curly brackets. That is going to be NP dot dot mean, comma, no, comma, then NP dot median. So let's see. Oh, so we're definitely going to run into an error there. So let's see the mistake we made. So for rice consumption, for the CO2 emission column, I want to calculate the mean and median for those column. So what's the error here? Python can be very tricky. Okay, print rice consumption. So what is my mistake? Oh, I didn't put my CO2 emission in quotes. That was my mistake there. Sometimes just a single quotes. Oh, what is the issue again? Let's see. Rice consumption, CO2 emission. Oh, I didn't spell my median very well. Oh, you can see. Just the spelling of median is giving me error there. So CO2 emission, put the column in square, then the median. It's going to be median, not median. So if you run this line of code, oh, but I still get my results. But I don't know why I keep getting this error while I'm trying. If I try to use np.median, I think I'll be getting this error over time. Let me see if I can troubleshoot this error. When I'm using numpy, I always get this error, but the result is correct. So our mean and median for CO2 emission of rice consumption data is 37.59. Yeah, 37.5 and 15, and the median is 15.2. So that's correct. Oh, listen again. So now, in this video, you learned, okay, given the scale of this data, what measure of central tendency best summarize the kilogram of CO2 emission per person per year for rice? Hmm, that's a tricky question. So what measure of central tendency best summarizes the kilograms of CO2 emission per person per rice? The mean is higher compared to the median. So in the video, you learned that the mean is the sum of all the data points divided by the total number of data points. So that is the mean, the sum divided by the. So the median is the mid value of the data sets. Should we say both? Because the median, should we say both? Oh, okay, that's tricky. Given the scale of the data sets, let's go for both. Oh, now take a look at the histogram. Does 34, the mean, seem like a good representation of the center of trend and tendency? Oh, that's true. Because when you look at the histogram, yeah, it's not even in the middle, but it is kind of skewed to the right more. This is 50, yeah. Mm. So is the median? Oh, the mean is higher than the median, correct? So what does that mean? So great. So the mean is substantially higher than the median since it is being pulled up by I value of over 100 kilogram. Pulled up by I value over 100 kilogram per person per year. So if the mean is higher than the median, mm, let's take a look again. The mean is higher here. You can see the mean is over 37. So the mean is being pulled up. Okay. The mean is the sum of all the data points divided by the total number of data points. And the median is the middle value of the data set where 50% of the data is less than the median and 50% of the data is greater than the median. Oh, so that means you need to have a good understanding of, as simple as mean and median is, you have to have a good understanding of the differences. Okay, so the question now is, given the scale of this data, what measure of sectoral tendency best summarizes the kilogram of CO2 emission? Oh, okay. The mean is higher than the median. So the mean is being pulled up by values over 100 kilogram per person per year. So when we look at the data sets, let's see. Okay, let's look at the rice consumption data set again. You can see some rice, some consumption and over 100 here. Okay, okay, okay. So the CO2 emission rather is over 100 here. So the median is the best represented. That's best summarizer of the whole data set there. Oh, interesting. Okay, I think I found a solution to this. Let me see. Oh, okay. So mean and median these statistics can be very funny. I'm trying to sort this error out. I'm coming. Let me see if I can sort this error out by removing the MP. If it is going to work. Mm. You see, it didn't work either. Oh, let's see. Voila. So I've sorted it out. So I could also use it like this and it's going to work. Oh, interesting. So I got same results. So I got rid of those errors. So let's continue and see what we need to learn here. So we need to look at measure of speed, variance and standard deviation, quartile quantities and quintiles, finding outlier using interquartile range. Oh, interesting. So we're like 35 minutes into the live stream. So let's learn about measure of speed today.
In this lesson, we'll talk about another set of summary statistics, measures of spread. Spread is just what it sounds like. It describes how spread apart or close together the data points are. Just like measures of center, there are a few different measures of spread. The first measure, variance, measures the average distance from each data point to the data's mean. To calculate variance, we start by calculating the distance between each point and the mean, so we get one number for every data point. We then square each distance and then add them all together. Finally, we divide the sum of squared distances by the number of data points minus 1, giving us the variance. The higher the variance, the more spread out the data is. It's important to note that the units of variance are squared, so in this case, it's 19.8 hours squared. We can calculate the variance in one step using np.var, setting the DDOF argument to 1. If we don't specify DDOF equals 1, a slightly different formula is used to calculate variance that should only be used on a full population, not a sample. The standard deviation is another measure of spread, calculated by taking the square root of the variance. It can be calculated using np.std. Just like np.var, we need to set DDOF to 1. The nice thing about standard deviation is that the units are usually easier to understand since they're not squared. It's easier to wrap your head around 4.5 hours than 19.8 hours squared. Mean absolute deviation takes the absolute value of the distances to the mean, and then takes the mean of those differences. While this is similar to standard deviation, it's not exactly the same. Squared deviation squares distances, so longer distances are penalized more than shorter ones, while mean absolute deviation penalizes each distance equally. One isn't better than the other, but SD is more common than MAD. Before we discuss the next measure of spread, let's quickly talk about quantiles. Quantiles, also called percentiles, split up the data into some number of equal parts. Here, we call np.quantile, passing in the column of interest, followed by 0.5. This gives us 10.1 hours. So 50% of the mammals in the dataset sleep less than 10.1 hours a day, and the other 50% sleep more than 10.1 hours. So this is exactly the same as the median. We can also pass in a list of numbers to get multiple quantiles at once. Here, we split the data into 4 equal parts. These are also called quartiles. This means that 25% of the data is between 1.9 and 7.85. Another 25% is between 7.85 and 10.1, and so on. The boxes in box plots represent quartiles. The bottom of the box is the first quartile, and the top of the box is the third quartile. The middle line is the second quartile, or the median. Here, we split the data into 5 equal pieces, but we can also use np.linspace as a shortcut, which takes in the starting number, the stopping number, and the number of intervals. We can compute the same quantiles using np.linspace, starting at 0, stopping at 1, splitting into 5 different intervals. The interquartile range, or IQR, is another measure of spread. It's the distance between the 25th and 75th percentile, which is also the height of the box in a box plot. We can calculate it using the quantile function, or using the IQR function from scipy.stats to get 5.9 hours. Outliers are data points that are substantially different from the others. But how do we know what a substantial difference is? A rule that's often used is that any data point less than the first quartile minus 1.5 times the IQR is an outlier, as well as any point greater than the third quartile plus 1.5 times the IQR. To find outliers, we start by calculating the IQR of the mammal's body weights. We can then calculate the lower and upper thresholds following the formulas from the previous slide. We can now subset the data frame to find mammals whose body weight is below or above the thresholds. There are 11 body weight outliers in this dataset, including the cow and the Asian elephant. Many of the summary statistics we've covered so far can all be calculated in just one line of code using the .describe method, so it's convenient to use when you want to get a general sense of your data. Time to practice measuring spread and finding outliers.
So in short term, you can just use .describe to calculate the summing statistics of the whole data rather than going through this stress. So let's give it a shot. If I go back up here and say food consumption, let me add the line of code below here. So I could just say food consumption or dot describe. Voila, we have our summing statistics here. Interesting. And see for each country by each food category. But let's make it simpler. If I go to this US consumption, that was the only data set. If I click on US consumption here, you can see all of this is US consumption. Let's do for the US country alone. So US consumption dot describe. Let's see. Voila. So it's going to US consumption for each food category. Pork. So this is the summary statistic for pork, for poultry, and so on. The challenge here, let me see. The challenge here is that it won't be easy if I'm using US consumption. So what I could do is just pick a column from here. Let's pick this consumption column. Let me go back up here and say food consumption dot describe, and I pick on a column. Let's pick on the food consumption, the consumption column. I'll just say open brackets, close brackets. Let me pick on the consumption column, consumption, consumption column. I think this is better. I can see this is much more better. So I need to close it with bracket there. Voila. You can see, so this is the count, the mean for the consumption column, the standard deviation, the mean, the 25th percentile, 50th percentile, 75th percentile, and the maximum number there. So let's do it better for this consumption here. So what did we actually calculate here? Calculate the mean consumption in US. So for consumption, US consumption, for this consumption, okay. Then I'll pick up on the consumption column, consumption. Let's see, dot describe. Aha. Look at the mean that we got. Look at the mean calculation that we did here. I see the mean here is 44. You see? Then the median, we got the median 14.58. The median is, where is the median? Uh, this is it here. Yeah, the 50%, which is also the median. 50% of 14.58. 14.58. So I prefer to use dot describe for this calculation rather than going through all the stress of calculating each statistical calculation one at a time. So if I do the same thing for this rice consumption, the mean, the median. So we did it for the CO2 rice consumption, column, data frame rather. So I want to pick up on the CO2 emission column. CO2 emission column dot describe. Let's see. Voila. So the mean, this is the mean 37.59, you can see. And this is the median 15.2, 15%, the median 15.2. So we prefer to use the describe. I know definitely a lot of people prefer to use the describe method rather than calculating this calculation using the .arg method one at a time. But it's good to know there are different methods to get same results. So let's continue. So let's look at variance. We want to learn how to calculate variance and standard deviation. I think we calculated variance from here. Is it there? Where is the standard deviation for this? Where is the variance? Let me see. Variance and standard deviation are two of the most common ways to measure the spread of a variable, and you practice calculating this in this exercise. Spread is important since it can help inform expectations. For example, if a salesperson sells a mean of 20 products a day, but has a standard deviation of 10 products, there will probably be days where they sell 40 products, but also days where they only sell one or two. Information like this is important, especially when making predictions. Pandas has been imported as PD, NumPy as MP, and Matplotlib as PLT. So the food consumption data frame is also available. So let's use the food consumption data frame again for one last time. So calculate the variance and standard deviation of CO2 emission for each food category with the group by and .arg method. Compare the values of variance and standard deviation. Oh, we need to calculate something a little bit technical here. So the variance and standard deviation for food consumption. So let's go on food consumption all the way from here. So we're looking at the old data set one more time. Food consumption. So we want to look at these large data sets. So we need to group these data sets again. So let's see. So calculate the variance and standard deviation of CO2 emission for each food category with a group by and .arg method. Food consumption. Okay, let's see. Then we need to create an histogram of CO2 emission for the beef in food category and show the plots. Okay, so food consumption dot group by. So we need to group by, want to group by the food category column. So I want to group this by the food category. So I'm going to be seeing one line for pork, poultry, beef, fish, and so on. So I'm going to say group by food category, group by food category. They want to calculate the CO2 emission column. For the CO2 emission, I want to calculate the standard deviation and variance for this column. CO2 emission, I want to look at the variance and STD. So this is going to be NP dot variance dot var comma NP dot STD. Let's see it in action here. Well, I can see the results, or we can see. But for my own, this error I'm getting, I'm just going to get rid of this NP and use this var. This method here, so I can get rid of those things. So we've grouped the whole data frame. It's over 1,400 rows of data. We've grouped using this line of code. We grouped by this food category, and we really calculated the CO2 emission, the variance and standard deviation for each food category. You can see is the variance for beef, the STD for beef, the dairy, eggs, fish, and so on. So the next thing is to create a histogram of CO2 emission for food category beef, for the food category of beef only. Okay, an histogram of CO2 emission is going to be dot east here. So CO2 emission, a histogram, okay. Okay, okay. Let's see. Create a histogram of CO2 emission for the beef in food category. Okay. Okay, let's see how to do that. Histogram food category. Okay. So for the beef, okay, it's going to be for the beef category. Beef. Okay, let me run this line of code first. Let's run this line of code. As we got this correctly, same thing we did here. So I want to double check the line of code. Sometimes it gets into error. Let the variance and standard deviation. Same results we got here. Variance and standard deviation for this record here. Let's do this second one. Food consumption. So food category. So food category or food category equals to beef. I say equals to beef. Let me see this in action. If you run into any error. Ooh, yeah, I guess so. Let's get up on the error and see our mistake there. So there's an error somewhere. Oh, I need to add food consumption again. Okay. Okay, it says create a histogram, food consumption. Oh, food consumption one more time. Okay. It's not to create a histogram. So this is very tricky. So I need to subset. I want to filter and create an histogram again. Oh, okay, let's do that gently. Food consumption. So I need to mention my data frame again. Food consumption. So food consumption data frame. So this is going to subset for the food consumption data frame based on the food category equals to beef. So I've subset for only the record for beef. Then I'm going to go to the food, this subset that have been subsetted and select the CO2 emission for my visualization. So I don't want to, so this is going to be for CO2 emission. Reading those things can be pretty CO2 emission column. Okay, let's see. So this is just subsetting this whole food consumption where the food category is beef. Yeah, I pick the CO2 emission column from it and show the plot. Let's run it again. Ooh, I'm missing something here. There's an error somewhere here. This line of code here. Okay. Food consumption. Then food consumption. So my mistake is here. And let's run it again. So oh, I'm still missing plt.show. Let me get up on the error. Let me see. For beef. Okay. Food consumption. Food consumption. I just want to read between the lines. I know where my mistake is. Food consumption, food category. I need to close it here. Then beef needs to be closed. So I need to close with one more bracket also. Oh. Okay. Then CO2 emissions over like I see. So this result I'm trying to get here. But let's see. Let me copy this. Okay, let me copy this and let's make use of it here. So we are subsetting for the food category column. If I get rid of this here and just say this food consumption, food category equals to beef. If I run this line of code, let me see if I can list it. So I can't run it like this. So it's missing something there. If I run all of it together, I shouldn't get any error. So just like the way we subsetted in this line of code here, it's subsetting we did here. So we're doing the same thing. You can see food consumption, food category. You see the food category column equals to rice. So we're saying the same thing here. The food, the food category column for food equals to beef. Then we just use food consumption again. Then we pick the CO2 emission column from this result here. So if I try to, okay, let me try to do this here. Let me copy this. And run this alone. You see the results here. So I'm just subsetting the data set dot edge. You can see, so only for beef, we're only looking at food consumption data frame for the food category where it is just beef. So we just join this CO2 emission, then we pick this CO2 emission column and added this line of code to it. Just to visualize this CO2 emission column of this food category beef in an histogram. And this is right skewed already. So that's what we did here. So the second one now says create a histogram of CO2 emission for X in food category and show. So we want to do the same thing, but this time it is for X. I'm just going to copy same thing here, same line of code here, and just drop it here. But this time I want to do for X. For X, if I run the whole code, that's it. So this is for X. So I'm just going to copy copy this line of code and show us in my Jupyter notebook here. So this is going to show us for X. So this for X. So to make sure you understand what we are doing here, also I'm just going to subset for only for X as I did it. So this for beef, this for X here. I'm just going to copy this code from here. Control C, add a line of code above and run it. Let's see what I can see. Now this is only for X over 130 rows of data. If I do the dot edge, we just filtered for those rows only. You can see. So this is for X. Then we just visualize the result of the CO2 emission column for X alone. And this is kind of, how would you call this? Is not right skewed, this is not left skewed, but we got the result we wanted. So let's submit and see. Superb spread measurement. Beef has the largest amount of variation in its CO2 emission, while X have a relatively small amount of variation. You can see this for X. You can see this is for X, and this is for beef. Hmm, interesting. So subsetting and good. We've been learning for the past 100 days. So let's see what we need to calculate in this last challenge. Oh, we have two more. Quartiles, quantiles, and quintiles. Oh, okay. We spent up an hour in this live stream. Should we stop here? Because we need to calculate the quartiles of CO2 emission column of food consumption. Calculate the 6 quartiles that split up the data into 5 pieces, which is the quintiles. of CO2 emission, column of the food consumption. They calculate the elevation 11th tiles of CO2 emission that split up the data into 10 pieces. Then we have another challenge to solve here. So we have a couple of challenges here. I think we should stop here for today because we spent an hour, exactly an hour, and the goal is just to spend an hour on the live stream because this is going to take a little bit of time, this last calculation. Okay, so we've learned all about quite a lot here, how to subset, how to visualize, how to do comparison and describe. So we've covered a lot. I'm definitely going to be reviewing what I've learned all over again, just to refresh my memory. So I'll be dropping the data set, this food consumption data set will be in the link under the description. So you just want to download the data set and also practice your statistical knowledge also in Python. So we complete this last part of the challenge of this chapter 1 on tomorrow's live stream. Let's just take a break today because this is quite a lot of calculation we are doing today. All right, so that'll be the end of the live stream for today. So if you find this live stream and learning journey useful, do well to give this video a thumbs up, hit that subscribe button, and I hope your head is not kind of hot like mine, trying to calculate some statistical data there. All right, so do enjoy your weekend. I'll see you on the next video on the channel or on tomorrow's uh, learning journey also. Do have a wonderful rest of the day. Bye for now.